One of the reasons I applied for this road test was that this is the first bench multimeter I actually own. I only had handheld multimeters like this Edgeland or this Unity before, and I wanted to have a look at how they compare to each other and what the different use cases and advantages and maybe disadvantages are for each of them. So let's have a look at comparing these two different kinds of meters. The first thing to notice is that they are quite of a different size and shape. So while when you take this meter here and compare it to the bench multimeter here, they are roughly the same size. The bench multimeter is a little bit larger, but the bench multimeter is actually like 25 to 30 centimeters deep, so you need much more space on your workbench to place it. So it's nothing designed to take around and place it wherever you want to. Whereas a handheld multimeter actually is something that fits in your hand. You place it wherever you need it. Can take it to field measurements when you're working outside, things like that. So that's one of the main differences. When we turn it on, we can see that usually handhelds are much faster in turning on. This one is quite fast with like 20 seconds or so. But basically handheld multimeters turn on immediately. In terms of the display, they are roughly the same size. The bench multimeter has a little bit bigger numbers. When we take this one for comparison, it has even larger numbers here. But none of these are backlit by default. That's something that you need to turn on explicitly because it will drain the battery. Whereas here the display is basically backlit, its color, so that's much nicer to read in many circumstances, so even when you have a dark work environment. That's something that is not as convenient with a handheld multimeter. Another difference is that a bench multimeter is always powered by mains power, so you can keep it on as long as you want to. There are no batteries that might be drained, whereas any handheld by nature is powered by batteries, and they have a different lifespan between, let's say, 100 hours and maybe 1,000 hours for a really good one, depending on the batteries that you can use. This one here actually is powered by a rechargeable battery, so I think it does not even reach 100 hours of battery life, but since it can be recharged, it's not as expensive to switch the batteries all the time. But you need to do that. It's a hassle because you need to remove the back cover with the screws or whatever the mechanics is, and need to replace the batteries. And as usually, they are always empty when you need the meter the most. So that's it in terms of the biggest differences, that's size and how they are powered. I will look more in depth in these two here, because they are roughly comparable in terms of price and specifications. I will do a more in-depth comparison, but this one is around 500 euros, this one is around 400 euros. So they are not exactly in the same ballpark, but they are roughly close. Both of these are 4.5 digit multimeters, so they have 4 full digits, and the first one here goes to 6. So it's 60,000 counts. This one is 50,000 counts, so they are not that far off. And they are of about the same accuracy. So in terms of voltage accuracy, this one here has 0.02% base accuracy, this one 0.025%, so roughly the same. And also the other ranges are mostly comparable between both. One bigger difference is that the HLand or Keysight actually has a millivolt range here, which can go down to 1 microvolt of resolution, which is something that the multicomp multimeter here does not have. Its lowest range is, or its lowest resolution would be 10 microvolt. That's something that you normally do not use, but when you want to measure small voltages and especially want to have a look how they change over time, in terms of, let's say, looking at a capacitor and how it discharges, things like that, or at voltage, or at reference voltages, it might make a difference, something that you need. In terms of usability, what's also easy to see is that usually, or actually handheld multimeters always come with a rotary range switch, and bench multimeters usually are driven by buttons. There are cheap bench multimeters which also use a rotary switch, but they are really of low quality, not of such high precision or quality. So all of the ones that are interesting in terms of precision, accuracy, and functionality are driven by buttons, and for that it means that the multimeter internally needs to use relays for switching all of the ranges and functionalities. That's something that you cannot do on a handheld multimeter, because relays just take too much power, and for a battery powered system you do not want to have that. So we have a range switch internally with multiple contacts doing all the switching, and this also means that usually you have kind of secondary functionalities here. That's something that you can see here, that for example you have a capacitance mode here and it doubles as temperature measurement, and you need to switch between these two. Similarly, the diode mode is used for frequency measurements, and that's something that you do not have here. Usually all of the different functions have their dedicated button: voltage, current, resistance, capacitance, frequency, temperature. So they are more easy to use because it's more easily visible what you actually want to do and what to which function to select, whereas here you need to look at, okay, which is the one that you actually want to use. Another difference is that usually the higher quality meters or higher precision meters come with 4-wire resistance measurement. So you have your typical buttons, ground, and you have voltage and ohms, and then you have ground and current. That's something that you also have here. And then you have the additional input checks for precision resistance measurements, where you have additional sense wires, so you can measure resistance to a much higher precision. That's something that I don't think any handheld multimeter has. Maybe there are some specialized ohm meters that have that. Another difference is that, especially with this Keysight here, is the meters are more robust, so they have very heavy duty shells, so you can take them out in the field, and even if you drop them they will not break. That's one of the reasons that you have. And the other one is that if something goes wrong and you, for example, have switched to current measurement and connected directly to mains voltage, and the meter explodes internally, or at least the fuse explodes internally, the meter itself will not hurt you, so it will contain whatever happens. That's something that bench multimeters usually are not designed for, and it also is visible in the CAT rating. This one here goes up to CAT 3000 volts. This one only goes to CAT 2, so it's not designed for measuring or taking measurements on high energy circuits. This one here claims basically or has basically the same rating, but it's not as robust, so I would probably not trust it that much. But it's also, you see, we have this rubber holster here, and it's designed to be taken outside, lying on your bench. You might throw your tools on it by accident, things like that, and it's designed to survive that. And a bench multimeter, usually it sits at the back of your bench, is not in the way. so it does not need to be as much protection as a handheld meter would need. In terms of usability, one of the other differences is that, say, by their basic philosophy, bench multimeters are designed to need or require more attention in terms when compared to a handheld multimeter, where you usually just select the function and that's it. So you say you want to measure voltages, maybe you need to decide between AC or DC, and basically that's it. And you want to keep any interaction with the meter as low as possible, because usually you are working on your circuit and taking measurement, and it should not be in the way. Whereas the bench multimeter with its buttons and additional functionalities provides more functionality, but also needs more attention when you use it. So a rotary switch is something that you can easily use even without looking at it. I know that when it's now on voltage and I just switch by one indent, it will be in the millivolt range, whereas for the bench multimeter I actually need to look at, okay, at which button do I need to press, and I need to hit it exactly. Similar here, when I want to switch ranges, I need to press this button, and it's something that you cannot do without looking. But then it has some special use, like maybe it has more precision. You want to do special histograms or historic value data logging, things like that. So it will probably not be your day-to-day multimeter, because the handheld multimeter most likely is more easier to use for this use case. I already mentioned that the handhelds are driven by rotary switches here, and you have secondary functions. So you can see that you have a number of buttons here. On top of that, 4 different functionalities, like switching between primary and secondary range, switching the ranges. You have a special button for the dual display here. Whereas the bench multimeter is more driven by an actual menu system. So you go to the range menu, and then you can select what the ranges are. You even have a next page here. Can select auto here. The speed just switches between the different functions, but each of the different functionalities has a different set of menus here. So you need to know in which mode you actually are to know, okay, what would be the menus that appear here and what do you need to select. And that's a bit of a difference to a handheld multimeter, where usually each of the buttons have their fixed functionalities, and they will not switch between the different functions. Even when, for example, here the shift button, which selects the primary and the secondary, will do something different in the different ranges, because there usually is a different secondary function. The meaning will always be the same. It will always be in the same place. The range button is always in the same place, things like that. So they will not differ between the different modes, and that's something that is different here. And for bench multimeters with even more functionality, like real math functionality, where you can do more complex calculations, this will be even more complicated. I think there are even nowadays multimeters that have a touch screen here, where you can probably zoom in, zoom out in your graphs and things like that. So that again means that a bench multimeter needs more attention when you use it, so you probably will use it only for cases where you actually need this functionality, or maybe where you want to do long time measurements, where you would not want to use your handheld multimeter, because it will just drain the battery, or it might just turn off by itself. And last but not least, Another difference between the handheld and the bench multimeters is that usually all of the, at least not actually the very cheap ones, bench multimeters come with external connectivity. So this bench multimeter comes with a serial port, USB and Ethernet. At least serial and USB is basically standard today. Ethernet sometimes is an option. You also might find a GPIB bus that usually is a paid option for meters when they come with it. This is very useful when you want to transfer measurements to your PC, when you want to automate stuff like combining measurements from multiple meters, or you want to drive a power supply, set specific values, and then measure the results here on the meter. And it's very, very useful when you can script these measurements. There are handheld multimeters that have an additional port, like this one here, where you can have an additional adapter for this infrared port here, which connects to a USB port. So you can do data logging and some basic configuration, so you can actually select ranges and things like that. But it will cost additional battery power, so it's nothing that you can run for several days in a row. And more simpler and cheaper meters like this one here do not even have a simple serial port here in the back. So if you have something like that, you just cannot log any measurements to somewhere else. The cheapest option that I have found so far for doing data logging measurements is this DMM shield from Digiland, which gets plugged into an Arduino or one of their Digi boards with the microchip processor on them. Unfortunately, it's not produced anymore, but it's very useful. Also has 5 digits of resolution, quite some nice ranges, and it's a great and quite inexpensive way to do real data logging. Without that, you probably are on your own or just need to use an Arduino, but it does not provide that much resolution and convenience like this Arduino shield here.